I was wondering if we needed to let people know at all. That is great. Okay, so hello everyone. Thank you so much for having me. I'm going to talk to you a little bit about retrofit in practice, basing that on the Passivhaus assessment that we conduct in Progress and Practice. Oh, I'm just going to check that in. There we go. Sorry, my name's Hannah Dixon from Progress and Practice. I'm the founder and the director here in our little studio. I'm an architect and I'm a Passivhaus designer and an AECV certifier. And at Progress and Practice, we specialise in retrofit, so low energy retrofits and Passivhaus design generally. So we work pretty much exclusively on low energy projects and try and make our projects as sustainable as we possibly can. The context that I'm talking to you today within is the Feel the Benefit scheme through the the chat's just popping up there. The Feel the Benefit scheme through GMCA's Retrofit Advice Service. So this is a service being provided by the Retrofit Consortium, which consists of Progress and Practice, People Powered Retrofit, Box, and Care and Repair. And so together we're offering a range of different approaches to retrofit assessments. So there's a kind of, if you log into the website, actually, if you see the link there on the right hand side, you can use the QR code on the left. You can have a look at all of the different options that are available to you in terms of what's most appropriate for what you're trying to achieve with your project, depending on whether it's a kind of large scale construction project or a kind of smaller. So there's an assessment process you can follow to find out a bit more about each option. So before we get too much into things, I thought I'd just give a bit of a kind of glossary of what I mean by certain terms. So specifically, retrofit is a term that is used, certainly in our industry. It's thrown around a lot and it can mean a lot of different things. So this isn't the definition of retrofit, but this is what I mean by retrofit. And this Progress and Practice, this is where we kind of work to in terms of a definition. So it's basically making a building, generally people's homes, more comfortable to live or work in, and making them easier to heat. And that's through improvements to the building fabric, so the construction of the building itself, and generally using a whole house or a whole dwelling retrofit plan. And that just means that when we talk about making homes warmer and kind of introducing retrofit measures, we look at that in a holistic way, so for the whole building, and make sure that all of the individual components that are part of that retrofit work together. The second word that I'm just going to introduce to you is, you might have heard of it already, but this is just a very basic kind of summary of what's involved in Passivhaus design. So the principles of Passivhaus design are basically the principles of building physics. So whether we're working on a Passivhaus or an Enefit retrofit project that's certified or a non-certified project, we always adopt these same kind of principles because they're essentially the way to make your home or your building as low energy as you possibly can. And so even if you're not aiming for certification, the basics of building physics still apply, obviously. And so the principles are, start with form. So we try and create a thermal envelope that is as simple as possible, because essentially we're reducing the amount of heat loss area. So the surfaces where you can lose heat through, we're making those as small as we possibly can relative to the building. And with a retrofit, that can be quite difficult because you're starting with a building that's already there. There might not be that many opportunities to change the shape of the building. But there might be small wins. So there might be things like recessed porches and other kind of little things that you can do to just minimize the amount of heat loss you have in terms of your thermal envelope. We then make sure we introduce insulation, and we introduce insulation everywhere. So it's walls, floors and roof. And we make sure that that insulation is continuous, so we don't have any gaps where your roof meets your wall, for example, or where your floor meets your wall. We work quite hard to make sure we detail really, really well to make sure that continuous layer of insulation through the whole building. And then the third one on the list there is airtightness, and that's something that's quite often misunderstood. So it's effectively what we're trying to do is stop air leakage. So we're trying to stop uncontrolled cold air coming into your building, which isn't useful because it's not going to the right places anyway, and it's just creating drafts and it's losing you heat through the kind of leakage. So in any project, making your airtightness as good as possible is going to have a really good impact in terms of your energy performance. So it's nearly as much as all of your insulation. If you get your airtightness right down to a very low level, it will save you nearly as much as insulating the whole house. But also it will make your home much, much more comfortable because you won't have those drafts everywhere. We then we make sure we have a really robust approach to windows. Now, that isn't just about specifying the right windows. So we do want very good, high quality windows, not necessarily Passivhaus certified windows, but very, well-made, airtight, and possibly triple glazed windows. But it also applies to the way that we design the windows themselves. So we want to make sure that we minimize the amount of frame, for example. So frames being the absolute worst part of your thermal envelope. And we make the windows nice and simple so that you get lots of daylight, but less heat loss again. And finally, the ventilation. So once you've made sure that your building and your home is completely insulated, nice and airtight, the last thing you want to do is then just put holes in it or open windows, but you may not want to if it's cold. Put holes in your building to let cold air in. That would be awful. So with a Passivhaus building, what we tend to use is an MVHR system, which is mechanical ventilation with heat recovery. But in retrofits, quite often there are different options that we can look at in terms of ventilation. So that might be things like it might be mechanical extract ventilation, demand controlled ventilation, different options that just make sure that you always get fresh air throughout your building. So you always have it when you want it, but you don't have those drafts that are just unhelpful and uncomfortable when it comes to energy performance. So that's the overall approach that if you're trying to minimize the energy demand of your home, addressing all of those things is the way to go. That's a kind of robust approach to retrofitting. And then you can start to think about renewable energy as well. So once you've reduced your demand as far as possible, so your energy demand, then you can generate to meet that demand. So what do we mean by retrofit assessments? So again, because the term retrofit has so many different definitions, so does the term retrofit assessment. Now, each of the retrofit assessments described within the field benefit service are slightly different and tailored to different situations, different circumstances, different budgets, and different types of projects. So from our point of view, we tend to work on quite large projects. They're always construction projects. And so we like to have a really robust approach to the retrofit assessment itself, because generally we're starting a project thinking that we're gathering that information in order to see that project through to the end of it. But it can also stand as a kind of standalone piece of work as well. So it can provide the basis for other people to then take on that project as well. But essentially the four components that we like to include within a retrofit assessment, it starts with a risk assessment, which is a bit of a desktop study. A client meeting, making sure that we've picked your brains about what it is you're actually trying to achieve with your project. A detailed condition survey, and then PHPP modelling, which is the Passivhaus Passivhaus planning package modelling. And I'm just going to go through that in a bit more detail now, just to give you a bit of a breakdown. So the initial risk assessment, the kind of desktop study, that is basically, it's making sure that we've done our homework in terms of the context of the building and your home. So we look at flood risk, we look at UXO is unexploded ordnance, so that is the potential risk of bombs in the ground and underneath your home. We look at radon, and we also look at the context in terms of planning policy. So that might be the national planning policy, but also the kind of local and regional policies that are in your area. And that might also include checking whether your building's listed, which we'll probably know from talking to you, but also checking whether you're in a conservation area and that kind of thing, so that when we come to have a look at the building itself, we really know the full context of what we're working with. And then we come and meet you, and we will review all of the findings of the risk assessment to make sure that we've got all of our information right. But we've also made you aware of all of the things that we've picked up during that process. Now, the picture that we have here is not just because we don't take pictures during client meetings, but because during the meeting we tend to have a bit of a Q&A, so it's almost like an interview, but not as formal or rigid as that. But it's basically us picking your brains about how you use the building, so how you use your home, and that includes questions like, where do you dry your washing and how do you dry your washing? It includes understanding how you operate. Do you have any ventilation? Do you open your windows in the morning and then shut them in the night? What are your habits around the way you use your building, and how's that going to impact in terms of a retrofit approach? So we basically go through all of that stuff and make sure that we're on the same page completely in terms of how you use your home. And then the final point there is just, so quite often when we start a project, we're not necessarily talking about just a kind of standalone retrofit. Quite often people want to talk to us about design work. And so that might include, some remodeling, it might include a bit of an extension, or it might be just a case of changing some of the glazing. But as part of that process, the very early stages of the project, we'd try and get a design brief together at the same time. So this meeting can work as a kind of a way of reviewing all of that stuff all in one and making sure that we're getting to know the building and we're getting to know you and your design brief at the same time. And then the condition survey. So this is a really detailed condition survey of the whole of the building. So it's inside and out. This is the bulk of our work when it comes to the initial assessments, because it's a very, very thorough, detailed room by room and then elevation by elevation breakdown of everything that is in your building. So we look at all of the construction of your wall and your floor and your roof. We pick up as far as possible where there are things that need fixing. So if there's, for example, brickwork that needs repointing before we make a start, or if we might find damp joists, for example, it means that we have a full picture of everything that needs to happen before we start to look at retrofitting and introducing insulation, talk about airtightness. So if, for example, your house needed a new roof before we make a start, we need to know that at the beginning so that that's budgeted for, and so that we've got a good idea about what the kind of sequence of works is going to be ultimately. And as part of that, we look at building services as well. So we make sure that we pick up all of your, the electrics, the ventilation, all of anything that might be relevant when you start building work, and might impact on how you approach a retrofit. And that all goes on into plans that go into this condition survey. So that you've got, firstly, it means we get to know your building really, really well. So by the end of this, we kind of know it inside out. We've got an up close and personal relationship with your house. But also it gives us a really good set of information to then pass on to someone else. So it could be that that is a piece of work and then gets passed on to another designer, or it could be that it goes all the way to be handed on to the contractor, the builder at the end of things. So this is, I think this is really a really important part of the kind of initial stages of the retrofit assessment, to make sure that to de-risk things, so things are picked up early, so that you don't then end up with issues later on. And then the PHPP modelling. So the PHPP modelling, the Passivhaus planning package modelling, it may not always happen in this order. So I've kind of set it out as one package, one retrofit assessment. But quite often, if people would like to have things like extensions and remodelling as part of the process, we'd normally do this after some of the design work has taken place, so that we're modelling what we know it's going to be like, as opposed to what it was like before. But essentially, it's a really detailed, roughly 40 tabs, I think, Excel spreadsheets. It is quite sophisticated, so it's not as basic as it sounds. But what we do is we input all of the geometry of your home into the spreadsheet. We input the specification of the existing house, and it outputs a base case. So it outputs what we call a space heating demand, which is essentially the energy that it takes to heat your home, if we assume that you're heating your home to 20 degrees throughout the entire year. So it gives us this kind of this space heating demand that is it's a base case for comparison. So then what we can do is we can create options on top of that. So we can start introducing insulation to your walls and your floor and your roof. And we can tell you exactly how much improving things by adding X, Y, or Z. And then ultimately, the goal is normally to have a specification of a full retrofit, and to be able to tell you quite often whether it's feasible to achieve the Passivhaus or the ACB standards. Or it might be talking about, well, what kind of improvement can we make? If we can't get to the benefit standard, can we have like a 50 or a 60% reduction? Not all of our projects use PHPP, so sometimes we advise people not to if we think that it's not going to be useful to them in terms of kind of decision making. But quite often people like to know, if you were doing a full whole house retrofit, if you were insulating your walls, your floor and your roof, and doing your glazing, the chances are that you probably would meet the ACB Carbon Light standard at least. And in which case you might like to know, and you might like to certify your home so that you can show that your project is not just any old retrofit. It is a very high quality certified retrofit. It also introduces overheating risk, so it can predict to a certain degree of accuracy, not completely, but it can predict overheating risk, and that's presented as the percentage of the year that your building reaches 25 degrees or over. And that's actually really useful in terms of planning whether you need to mitigate overheating as part of your retrofit strategy. So it might be a case of introducing shutters or blinds to the outside of your home to make sure that you don't then get a lot of heat from the sun, which you're then not able to lose very quickly because you've insulated your building. So that's a really useful part of the PHPP modelling. Now, as I've kind of hinted at or said a couple of times, we don't normally just do one package. So what we tend to do is work on projects throughout the whole design process. Now, if your project involves remodeling or extending, then it definitely will need a full set of construction drawings as part of that. And actually, most of the projects that we work on, all of the projects we work on, even if they're just retrofit, would need that level of detail as well, because they're construction projects. You know, they're multiple different retrofit measures or energy saving measures that come together, and they need to be properly thought about in terms of the way they all go together. And so the way that process works is pretty much the same as other architects. So it's a kind of it's the RIBA work stages. So I've got 0 to 6. It goes up to 7, and 7 is in use. But yeah, it's very, in terms of retrofit and in terms of that kind of construction process and design process, it's very much the same as kind of regular design work. So you would normally start off at stage 0 with the design brief, and that's the questionnaire that we would normally send out with a whole list of all of the things that we really need to know before we start a project. Stage 1 would then be your retrofit assessment. So that's testing the feasibility of what you can do with your home. If you were doing design work as part of that, so if you're doing extension and remodeling, at that point we'd also look at doing sketch options. So we'd do some, what we've got on the right hand side there, which are essentially, we don't just arrive at one design for a project straight away. What we tend to do is have quite a collaborative process with our clients, and we normally start off by preparing 2 or 3 sketch options, which as closely as possible meet the brief in some cases, but then quite often what we like to do is produce options that test the brief and push the boundaries a little bit. And then we have a workshop where we come together and work out exactly what we need to take forward. But it's that kind of stage of divergent thinking and bringing all the ideas together. So that can actually be part of the retrofit design process as well, depending on how much change you want to see as part of that process. I guess the reason that people do like to think about these things at the same time as retrofitting is that it quite often is, you know, like I said, it's a construction project, and so you're having quite a lot of disruption and cost. And so you quite often want to think about these things as you're doing it, to just make sure you've made the most of that opportunity. And then I'm just going to mention very quickly about principal designers and principal contractors. So because we're talking about construction projects, all construction projects require a principal designer and a principal contractor under building CDM regulations. And I'm not going to talk about that at all, but I'm just going to mention it very quickly because any project requires that, so it's just something to look up, but it's not included in the rest of the presentation. So I'm just going to move on. So we've kind of talked about retrofit assessments and the design brief a bit already, but we can maybe touch on stage 2, which is concept design. So once you've arrived at your workshop and you've gone through all the options for your project and you've arrived at one layout, we then start to add details to that. We start to work out exactly what it's going to look like, what it's going to feel like on the inside, on the outside, what sort of materials might be used. And again, because we like to, where possible, specify low carbon materials, so we can be looking at natural materials for the internal finishes. We can use timber cladding externally, or other low carbon materials where possible. And at this stage, there's not much difference to a regular design process, other than you're just thinking about at the same time the impact of the decisions that you're making as part of the design process. So if you are, for example, in this case, we have some really large sliding doors to the south elevation on this project. And so when we're looking at the sketches of the outside of this, we were looking in awnings, shutters, shading devices to make sure that that's not something that's overlooked. It might be a case of kind of building in, making sure you've got really thick walls if you've got an extension, or just considering where your insulation layer is going to go, so making sure that you can accommodate the insulation in certain areas. But it's not too different from a kind of normal process really at this point. When you move on to develop design, that's when we start to get more formal in terms of our process. We produce plans and elevations. We tend to put onto those, we obviously put on the insulation strategy because we need to make sure that that's accommodated and that we know what it's going to look like. But we also introduce the ventilation strategy. So in the case of this project here, we've got you can't see it very well, but we have got an MVHR kind of schematic put onto the drawing so that we know how that's going to work. We know that that can fit within the space and where the ducts are going to run more or less, so that once we get beyond, say, the planning stage, there are no kind of surprises about what will or won't work. And I've mentioned planning, but generally, typically, quite often, planning applications are required. So if you've got any external wall insulation, unless your house is already rendered and you're matching the render that's on it, generally you'll require a planning application because you'll be changing the appearance of your home. If you've got internal wall insulation, you're less worried about it. And at this point in the project, we generally recommend getting some cost advice as well. That can be working with a cost consultant or with a builder. And when we're here, before we go to planning, before we submit everything, at this point it's a good idea to do the PHPP modelling, because this is when you can really, firstly, the design's fixed, so you know exactly what you're working with and what we're aiming for. But it also means that you, if there are any changes that need to happen, if you want to make a window a bit smaller, a bit bigger, then you can do that before you go to planning, and there's no risk of having to go back and forth, which would be expensive and a pain. The kind of the biggest part of our work is the technical design at stage 4. So if you get planning, then the next stage is to go into detailed design, technical design. And what that involves is a lot of drawings that look a little bit like the one on the screen. So this is a 1 to 5 technical detail of what we call an eaves detail. So it's the edge of the roof. And what this shows is what we need to achieve, which is the thermal continuity. So what you can see here in the pink is the insulation. And as you can see, there are no gaps in the pink. We've got a continuous layer of pink insulation. It's not actually pink, but we use that colour so that we can visually see really easily that we've got that layer consistent throughout the whole building. We always mark on our drawings the airtightness layer, because this will demonstrate to us and the builder how we're going to achieve an excellent level of airtightness. And you can see the little circles are circling where you put your airtightness tape. And then we want weather tightness, because naturally you want your building to be weather tight. At this point, it's quite likely that you'll need other consultants as well. So it might be a structural engineer, it might be building services engineers, depending on the scale and the complexity of the project. And you'll probably also need to do, a PHP update to make sure that the detailed design, any little changes, because there will be lots and lots of little changes that come out of that process, but all of those are picked up and reflected in the PHP, and you're still getting where you need to be if you're aiming for certification. And at that point, what you generally do, if you're looking to reach, say, the NFIT standard, what you'd need to do is submit that information to a certifier, which is a third party who checks all of our information and says, yes, if you do all of that stuff, you will have a Passivhaus NFIT project. If you want an AECB certified project, then that's something that we can look at in-house. And so that's a slightly easier process. I've skipped quite a lot here because we're going straight from technical design to construction, and there's a whole process of finding a builder and making sure that you're working with a builder who you really you trust and you know can do the kind of work that you want doing. And it is really important to be confident that they buy into the process and the approach that you're going for, because it requires a really excellent attention to detail when you get onto site. So all of that airtightness taping that I kind of hinted at in the drawings, it requires people being really meticulous about the way that they work. So having a builder that you absolutely trust to do that is really, really important. When you get to start on site, our role changes slightly in that we act as a kind of intermediary generally between you and your builder. So what we'd always recommend is a formal contract between yourself and your builder, and we would administer that contract as a third party to make sure that you've got someone impartial who can say, interpret the contract and tell both sides exactly what's fair and what's right within the kind of the process. As part of that, we generally provide site support, so we answer all the queries, and we give guidance in terms of the approach and how you can deal with things that do come up on site. So even though we try and design as much as possible beforehand, there generally is always something that comes up. And we like to generally have a collaborative approach with our builders. So we like to work as a team. That's the client, the contractor, and the architect working together, all pulling in the same direction and making sure that we're working positively to resolve things. And as part of this this kind of site stage of work, if you're going for a certified project, what you have to do is to prove that that you have achieved what you said you were going to achieve. So where you've modelled things in PHPP and you've drawn all of your drawings that work with that, you then need to show through pictures of installed insulation, delivery notes, and all of the evidence that demonstrates that you absolutely have achieved that. And that includes doing things like airtightness pressure tests. And for that, you need to make sure that you get to a very, very good standard. So for any certified project, you're really looking at either 2 or 1 air changes, which is roughly 10 times better than you probably have in your house at the moment. And then finally, there's the handover. So once all of that, and again, that makes the construction processing really short and easy. But when you get to the end of the handover of the construction process, there's the handover of information, and that's the health and safety file. So that's all of the important stuff in terms of those CDM regulations that I've mentioned already. You should have a set of as-built drawings which reflect any change that's happened during the construction project. And you will need to make sure you get your sign-off from your building control officer, and any information that you need from the contractor in terms of warranties and anything else that's gone into the building. In terms of the certification process, what you would end up having to do then is submit all of that evidence that's been gathered throughout the process and send that to the certifier. If it's a passive house project, what they'll do is they'll review it and they'll ask you queries and they'll come back to you. And when I say you, I mean me. So this is our job as architects or passive house consultants. And so they'll ask us queries and we'll go through and quite often have to send a bit more information or kind of respond to things. And when they're happy with that, that goes across to Germany, to the Passive House Institute, and they'll check off everything and hopefully then send us a certificate in the post. If it's an AECB certified project, it's a slightly different process, but there's a final lot of information that just needs checking over and submitting before you get your certificate. And then I was just going to talk through a quick case study. So this is the Park House Retrofit project in Stretford. You might have seen this project if you've watched. There's Guy Martin's House Without Bills on Channel 4. So this was the feature project, which he did not build, but he did help out on a couple of things. So when we started this project, the brief was very much to turn it into a kind of, it's a bit of a cliche, but a forever home for our clients. So they wanted it, they're retired, and they wanted it to be accessible and usable, you know, for the foreseeable. So we introduced ground floor living and a shower room on the ground floor to make sure that if necessary they can at some point use that as a bedroom, the living room. And then the rest of the house we extended at the back to make sure that they had enough living space on the ground floor, improved the flow of the whole floor plan, and retrofitted everything so that it was meeting the Passivhaus benefit standards. So for the construction process, it's fairly difficult to summarize absolutely everything all in one, but what you need to be aware of is that, as I said before, the builder needs to have a really good attention to detail. They need to be working with the architect or the Passivhaus consultant directly, and they need to be on board with delivering exactly what's on the drawings, because if not, then you'll miss your target. Everything is checking, and ideally you have a no blame culture. So obviously we've talked about collaboration, but this goes a little bit further in terms of because airtightness in these projects is so precious. If someone makes a hole in the airtightness layer, we really need them to tell us about it, as opposed to hiding it and then running away. So having this kind of no blame culture is really important, and quality control, checking everything is just essential. One of the things that you'll find with any retrofit project, and I'm just going to talk through the kind of different elements of the retrofit as we go through, but with any retrofit project, one of the biggest risks is the existing structure. So on this particular project, we had a number of surprises. One was that the bay windows, the pediment, the top of the bay window was made of solid brickwork and was sat directly on the hollow PVC window frames. And as we looked down the street, we could see that actually there was quite a lot of movement in different people's bay windows. What we couldn't do was then reinstall windows with a bunch of brickwork unsupported on top of them. So we ended up having to rebuild the bay window, as in the structure of the bay. We found that the internal walls were created from a kind of blockwork that was so soft that you could stick your finger through it. So they ended up built as stud work. The external walls were bowing, so the cavity wall ties ended up having to be replaced, retrofitted. And some of the roof, you can actually see it in this picture here, required reinforcement to make it fit for purpose for another 100 years. And that's just some images of that's the bowing wall on the left and the reinforcements in the roof structure and the missing bay on the right. So our approach to airtightness on this project was wet plaster on the walls, and then a service void in front of that. As you can see there, we've got membranes to the ceiling, which are then taped onto the walls. So every element, the walls, the roof and the floor, have their own airtightness strategy. It's then got connection detail between the two. These are actually some notes that the builder wrote about what you need to look out for. So you need to build in tolerance. You need the attention to detail again. I'll just keep saying it. And actually, having mock-ups on site is a really useful way of letting people know what good looks like. So if you have pipes that have been taped up, so that people can see what they are aiming for, it's just a really useful way of working. And then the last thing is when to test. So what we tend to do with low energy projects is make sure that we build in at least 3 pressure tests throughout the project, so that we don't just get to the end and find that we've failed. Instead, we do it when we've first completed the airtightness. So just after this, actually in this image, once the windows are in and have been taped up, at that point you do a pressure test. And at that point, you can see all of the airtightness, so you can actually address any issues that come up as part of that. With dirt, that would then normally do one after first fix. So once people have come in and made a lot of holes, do another pressure test before things get covered up again. And then the final one's at the end, which is the certificate that we need for certification and for building, well, not for retrofit actually. And there's Guy talking about some airtightness and the pressure test happening on site. So that is probably the first one I expect. For insulation, we had wood fibre on to the front of the house as internal wall insulation. So that is that's basically because we wanted to make sure that the front of the house retained its existing character and looked appropriate in the street scene, partly to get planning and partly because we thought it was the right thing to do. Where we have thermal bridges where the internal walls meet the external wall, we've used special, very expensive aerogel insulation to avoid a thermal bridge. We then have mineral wool to the back of the house as external wall insulation, because the back didn't matter so much, didn't have beautiful brickwork or anything like that. So it looks quite smart with a kind of rendered finish. And then we have cavity wall insulation as well, so EPS beads in the cavity. The loft was topped up with extra mineral wool, and we've got a new insulated airtight floor slab. And then the new extension is actually built out of timber, a very thick timber frame using timber eye joists and recycled newspaper insulation. And there you can see on the left-hand side the external wall insulation, and on the right-hand side that's some internal wall insulation, and that's the aerogel, the very fancy aerogel insulation. That's again, it's mitigating the thermal bridge of that brick wall on the right, where it meets the external wall on the left. The glazing on a passive house project, you just have to have high quality triple glazing. I generally recommend triple glazing anyway, because it is a really good way of improving your comfort. And even if you go for the absolute best windows that money can buy, they will still always be the worst part of your thermal envelope. So on this project, I think we did have Viking windows with Eco Homes windows. Again, there's always a bit of a balance to be had in terms of design. We tried to design out the frames as much as possible, but we did also want to keep in with the street scene as well. So if you see the picture on the right, it shows the bay window at the front. And again, we wanted to just keep in with the kind of rhythm of the existing buildings. The installation of the windows is really, really important, because firstly, we want to make sure it's airtight all the way around the edge of the window, so the four sides of the window. But also there's a potential for gaps in the insulation around that edge as well. And what we really want to do is make sure we bring all of the insulation all the way up to the frames from all angles. And they're very, very heavy as well, so just be aware of that. Tell your builder. And for ventilation for this project, it's a Zender Comfo Air 200. It's a Passive House certified MVHR unit. I would absolutely recommend, if you're going for MVHR, looking at Passive House certified units, because they are extremely efficient. This one I think is a 92% efficiency MVHR, which means that you're recovering 92% of the heat that you're extracting from your building is being recovered, which is super. And they're also very, very quiet. And there's a few things to think about with retrofit, because it's quite challenging to install ductwork in an existing building. So again, it comes back to this thing of having a plan right at the beginning and really considering all of these things before you get to the point where you're on site. So make sure that, have a think about whether you want to see your ductwork or not. If you want to see it, you can do some beautiful things with steel ductwork, exposed steels ductwork. If you don't want to see it, probably you want to go for the semi-rigid stuff, which is very sort of much smaller and can be thread through the building. But you'll require a lot more ducts in that situation. So it's just working out what the best fit is. You might need to include service voids for ducting, so kind of gaps in the construction where you can run your duct through. And you must insulate your intake and your exhaust very well and tape it all up to avoid condensation and heat loss. And you need to make sure you get it commissioned so it works really well as intended. And here are just a couple of, those are the ducts that I described on the left-hand side. So those are semi-rigid ducts. And that was a riser that came all the way from the loft all the way down through into the ground floor rooms. And on the right-hand side, you can see those are the pre-insulated pipes that then get another layer of insulation on top of that afterwards. So those are only 2 points in the house where the ventilation goes through to the outside. And then once we've done all of that, so we've reduced the energy demand, like I say, all the way down to 25 kilowatt hours per metre square per year. And then we can meet that demand using a very small air source heat pump. I think it's a 3.5 kilowatt from memory. And then we have a few solar panels and some battery storage, because that just means that they're quite compatible, because we're switching by going with air source heat pumps to electric. We can then meet the demand of that air source heat pump using solar panels on the roof. These just some pictures of those. And finally, aside from the kind of energy performance side of things, we also, with this project and generally really like to use natural materials because they are lower in carbon, they're generally healthier, they don't give off VOCs in the same way, they're not derived from crude oil, and they just have a beautiful texture and warmth that really adds to your internal and your external spaces. So it's definitely something to think about. And then we'll just have a few pictures of the final project. The outside, the internal spaces and the details, the timber cladding, and the internal spaces again. I'm aware I've spoken for far too long, so I'm sorry.
No, that is perfect. We have 10 minutes left if anybody had any questions on Hannah's presentation. I love those pictures at the end. I think they're really beautiful. They just, as you say, it's like got that warmth and that it's just such a beautiful house. If anybody would like to raise their hand to ask any questions, if there is any? Yes, Molly, please go ahead.
Hi, Molly.
Oh, you might be muted. Let me see if I can help.
Hi.
There you go, can hear you now, yeah.
I just wanted to ask, how do you tie in a DPC to the wall in the Guy Martin house? I'm calling it Guy Martin house, but I know you did a solid floor from a suspended, but I couldn't see how you do the membrane into the original DPC.
So you don't necessarily, I mean, what we do is take the DPM back to the air tightness on the walls, and then externally we have a break in the external wall insulation between what's above ground is the mineral wall that I mentioned. What I didn't mention is that at DPC level we have a break in the insulation and we go to XPS, which is a closed cell insulation. But in terms of actually, we can't get the DPM into the DPC as existing, if that's what you mean.
Yeah, no,
so,
yeah, I
so
think
it's connected to the air tightness on the walls instead of the
I have a bitumen layer, so I was thinking, do you tie it in with that? But someone says not necessarily so. You can finish it. I know I'll have to get a surveyor in anyway just to tie it all up, but it's pretty hard trying to mitigate damp in the older houses, I think, is the hardest bit.
Yeah, so moisture risk is definitely a huge part of why doing a retrofit assessment at the beginning is really important, so that you can identify, firstly, if you've got any damp anywhere already and how to address that, but then also make sure that you don't then build in issues later on. So looking at the kind of the type of construction, you know, if it's a traditional solid wall or if it's, I don't know, a 60s cavity wall, is going to impact how you select your materials and how you detail that. But it's a good point, yeah.
Yeah, I had a retrofit assessment, but I don't think it was really that good. I think it's very difficult in a retrofit house where you're not doing a full retrofit. I think the company were used to doing full retrofits. Instead, I can only do bits at a time. But yeah, I take on board what you say. It's a good thing to have.
I mean, I think, yeah, certainly having, even if you're not going to do a whole retrofit right now, having a plan for what you might do in the future is really important, because it just means you're not going to do things now that stop you from doing things in the future, or that you have to undo, because that would just be horrible to have to, you know, to have wasted. Yeah.
Thank you.
Thank you.
Tom, you would like to go?
I guess mine's the obvious question of costs, really. How much was the assessment? How much did it cost to do the work? And how much did the value of the property increase, and those sort of things? Because I'm very conscious of the best being the evil of the good. And what's good enough?
What's good enough? That's a very good question. So what I'm not going to do is tell you the cost of this project, because my client's kind of private information. What I can tell you is that most retrofit projects that we work on are probably upwards of 150,000, where it's a whole dwelling retrofit. So if you're aiming for insulating and doing the glazing and airtightness and everything, and that probably, if you're starting with a small house, probably 100,000 is a realistic starting point for everything. In terms of the retrofit assessment, it does depend on how much, you know, which of those sections you need, how big your house is, and all of these other factors. For the complete, for everything, I think we've got a starting price of around, I think just shy of £3,000. So to do, you know, the detailed condition survey and all of those things, plus the PHPP modelling, all in. But again, it really depends on the exact specifics of your home.
Okay, thank you.
And in terms of cost increase, as in value of your home, I can't answer that at all.
Yes.
Because it's upsetting that these things aren't valued as much as they should be, maybe.
Do we have time for maybe one more question if anybody else has one? If not, we can end it. Okay, great. Well, thank you so much for joining us. Thank you so much to Hannah. I will try and circulate the recording if people would like to see it again, if you'd like to go back through. But yeah, thank you so much. We are looking to do kind of other webinars about different retrofit assessments and different styles. As we've mentioned, this is part of a GMCA funded project, so looking at different retrofit assessments and making that more accessible for individuals. So yeah, thanks to Hannah for actually being our first person. Thank you very much.
Thank you so much for having me.
Stop the recording.